Here we have a very nice but very challenging problem. We're given the equation of a circle and a point on that circle, and we're told that the tangent to the circle at that point meets the x-axis at point P. And then we're asked to find the area of the triangle OAP. So the first thing we need to do is draw on our point A. It's at 2, 6, so it'll be somewhere up here, doesn't matter exactly where, but in that vicinity. The next thing we'll do is draw the tangent. A tangent is a line that just touches the circle, never crosses it, so if we zoom in it should just touch it but never actually go over the black lines. So we can label the point at the top A, and where that tangent crosses the x-axis, we were told that's point P, so we'll label that as point P as well. The next thing we'll do then is draw in the other line for the triangle. We have AP, which is the tangent, we have OP, which is part of the x-axis, so we just need to draw in OA. OA is going to draw in the centre of the circle up to the point that we found on the circle, i.e. it's going to be a radius of the circle. So now that we have a radius of the circle, and we also have a tangent to that circle, we know that these two always cross at 90 degrees to each other, i.e. a right angle. So now we've got our entire triangle, we can figure out that we're trying to find the area of this triangle, i.e. this blue section here. So the next step in this problem then is to find the gradient of the line OA. To do this, we use the difference in y's over difference in x's. So the y coordinate of A is 6, and at the origin it's 0. And for the x coordinates, we're going to have 2, take away 0. So this ends up being 6 divided by 2, which is just 3. Next then, we're going to take this 3 and use that with the fact that we've got a right angle between the radius and the tangent. So whenever we have that, the two gradients are the negative reciprocal of each other. So that tells us that the gradient of AP is going to be negative 1 over 3, or 1/3, whichever way you want to think about it. Now we can use that gradient to find the equation of the line AP. To do that, we'll use y minus y1 is equal to m lots of x minus x1. So let's sub in what we know. We know that y1 is 6. We know that x1 is going to be 2. We know that the gradient is going to be that minus 1/3 that we've just found. And now we could put y in there, but the entire reason we found this line is to find the x coordinate of the point P. We know the y coordinate of P is 0, so we can just stick that straight in there and then solve this equation for x. So we can cancel out these two negatives, and then we'll also multiply by 3 at the same time to give us 18 on the left, which is going to be equal to x minus 2 on the right. So all we have to do is add 2 to give us that x is going to be equal to 20. So this gives us the coordinates of the point P. We know P is now going to be 20 and 0. So we've now figured out everything we need to know. So if we redraw the triangle, we can start to fill in how long the sides are. We know that the base is going to be 20 long and that the height is going to be 6. So using the formula for the area of a triangle, we're going to have half times base of 20 times a height of 6. Half of 20 is going to give us 10, times that by the 6 gives us 60 altogether. So the final answer to our question is going to be 60.